For decades, scientists have relied on established models to explain the universe's expansion, its structure, and the forces that govern it. But what if those models are incomplete, or even wrong? The James Webb Space Telescope has just uncovered something that could shake the very foundations of cosmology. Nobel Prize-winning physicists are now warning that these latest findings might force us to rethink everything we thought we knew about the universe. Is our understanding of the cosmos fundamentally flawed? And if so, what unimaginable secrets are waiting to be uncovered? The universe, as we know it, is a vast, mysterious expanse filled with galaxies, stars, and cosmic phenomena that have fascinated humanity for centuries. But what if everything we thought we knew about the cosmos is wrong? What if the very foundations of our understanding of the universe are being challenged by groundbreaking discoveries? This is precisely the scenario unfolding as the James Webb Space Telescope, 9WST, peers deeper into the cosmos than ever before, revealing strange and inexplicable phenomena that are leaving scientists baffled. Nobel Prize-winning physicists are now warning that these discoveries could force us to rewrite the textbooks on cosmology. The universe, it seems, is far stranger and more complex than we ever imagined. Professor Rees initially used the Hubble Space Telescope to measure the distance between a set of different galaxies. This revealed that the universe's expansion was accelerating at a rate of 72.8 kilometers per second per megaparsec, a distance equal to 3.26 million light-years. What made this result so surprising is that the conventional wisdom about the evolution of the universe suggested this figure should only be 67 to 68 kilometers per second per megaparsec. This had the shocking implication that the standard model of cosmology might be missing out on something vitally important, creating what astronomers call the Hubble tension. More than 25 years later, Professor Rees has now used NASA's biggest and highest-performing telescope to prove that his Nobel Prize-winning discovery had not been an error. Using the JWST, Rice and his co-authors focused on a set of galaxies containing pulsing stars called Cepheid variables. These unique stars flash at a rate which is proportional to their brightness, or luminosity, which makes them the gold standard for measuring interstellar distances. Although the sample size was smaller, the team managed to take measurements about 4 times as precise as the previous study. In addition to Cepheid variables, the researchers also took measurements from carbon-rich stars and the brightest red supergiants across the same galaxies. This allowed them to further cross-check their results to be absolutely certain their measurements were correct. These new recordings revealed that the galaxies were accelerating away from each other at a rate of 72.6 kilometers per second per megaparsec, nearly identical to Hubble's measurements from the very same galaxies. Professor Rees says, "The discrepancy between the observed expansion rate of the universe and the predictions of the standard model suggests that our understanding of the universe may be incomplete." With 2 NASA flagship telescopes now confirming each other's findings, we must take this Hubble tension problem very seriously. It's a challenge, but also an incredible opportunity to learn more about our universe. This implies that we might be missing something vitally important about the birth of the universe. Sheng Li, a Johns Hopkins doctoral student and a study co-author, says, "The Webb results can be interpreted to suggest there may be a need to revise our model of the universe, although it is very difficult to pinpoint what this is at the moment." The James Webb Telescope's revolutionary glimpse into the early universe. Since its launch, the James Webb Space Telescope has been hailed as a game-changer in astronomy. With its unprecedented ability to observe the universe in infrared light, the JWST has provided us with a clearer view of the cosmos than ever before. But with great power comes great responsibility, and in this case, great confusion. One of the most startling discoveries made by the JWST involves the earliest structures in the universe. When astronomers pointed the telescope at a seemingly ordinary patch of sky, They were met with an image filled with strange, bright splotches. These splotches, or blobs, as some scientists have called them, are unlike anything we've seen before. When you look at this image, there are lots of splotches all over the place, says one researcher. But one of them stood out immediately. It was incredibly bright, and our initial reaction was that it couldn't possibly be as distant as it appeared. Bright objects in the early universe are supposed to be rare, if they exist at all. To investigate further, the team took spectroscopy data, which allowed them to measure the distance to the object. What they found was astonishing. This bright blob was not just a distant galaxy. It was one of the most distant galaxies ever observed, dating back to a time when the universe was just a fraction of its current age. The Standard Model explains the evolution of galaxies, the cosmic microwave background from the Big Bang, the abundance of chemical elements in the universe, and many other key observations based on the known laws of physics. However, nothing that scientists have been able to observe explains why the universe should be accelerating at such a rapid rate. Scientists believe the regular matter we can see and interact with makes up just 4% of the total universe. The remaining 96% of the universe is made up of dark matter, which makes up the missing mass in some galaxies, and dark energy. Dark energy could make up as much as 69% of the universe and might provide the force responsible for space's expansion. However, with the nature of dark energy remaining a mystery, scientists are still no closer to resolving the Hubble tension than they were back in 1998. Professor Rice says, "Yes, it appears there is something missing in our understanding of the universe. Our understanding of the universe contains a lot of ignorance about two elements, dark matter and dark energy. A universe that defies our understanding. The discovery of such a bright, massive galaxy in the early universe poses a significant challenge to our current cosmological models. According to the lambda cold dark matter, lambda CDM model, which is the standard framework for understanding the universe, galaxies in the early universe should be small, faint, and relatively simple. But the objects observed by the JWST are anything but. These galaxies are too massive, too bright, and too evolved for their age, explains one astronomer. According to our models, there simply wasn't enough time after the Big Bang for these galaxies to form. They shouldn't exist, and yet there they are. The implications of this discovery are profound. If the lambda CDM model cannot account for these galaxies, it suggests that our understanding of the early universe is fundamentally flawed. Some scientists are even beginning to question whether the universe had a definitive beginning at all. The conventional understanding is that the universe began with the Big Bang approximately 13.8 billion years ago, says a Nobel laureate. But these observations are making us wonder if the universe might be much older, or if it might not have a beginning in the way we've always assumed. The Hubble sphere and the limits of the observable universe. To understand the significance of these discoveries, it's important to revisit some of the key concepts in cosmology. Since 1929, we've known that the universe is expanding. This expansion is not like an explosion, where objects are moving away from a central point. Instead, space itself is stretching, causing galaxies to drift apart. This expansion has a peculiar effect. The farther away a galaxy is, the faster it appears to be moving away from us. In fact, beyond a certain distance, known as the Hubble sphere, galaxies are receding faster than the speed of light. This might seem impossible, but it's a consequence of the accelerating expansion of the universe. Despite this, we can still observe light from galaxies beyond the Hubble sphere. This is because the Hubble sphere itself is expanding, bringing these superluminal galaxies into our observable range. However, there is a limit to how far we can see. This limit defines the observable universe, which is approximately 92 billion light-years across. At the edge of the observable universe, we see the cosmic microwave background, CMB radiation, which is the afterglow of the Big Bang. This radiation provides a snapshot of the universe when it was just 380,000 years old. Beyond this point, we cannot see anything, as the light from those regions will never reach us. One of the most remarkable discoveries made by the JWST is a galaxy known as JADESGSZ14. This galaxy exists at the very edge of the observable universe, and when we observe it, we are looking back in time to when the universe was just 290 million years old. This galaxy is a time capsule, says one researcher. It shows us what the universe was like in its infancy. But what's truly astonishing is how bright and massive it is. According to our models, galaxies like this shouldn't exist so early in the universe's history. The existence of such galaxies challenges our understanding of galaxy formation. Normally, galaxies form gradually as gas and dust coalesce under the influence of gravity. But the galaxies observed by the JWST appear to have formed stars at an unprecedented rate, turning 100% of their available material into stars. This is completely unexpected, says an astronomer. Our models suggest that only about 10% of a galaxy's gas should be converted into stars. But these galaxies seem to have defied that rule. It's as if they found a way to cheat the system. The discoveries made by the JWST are not just challenging our understanding of galaxy formation, they are shaking the very foundations of cosmology. For decades, scientists have relied on the lambda CDM model to explain the universe's structure and evolution. But this model is now facing a crisis. The lambda CDM model has been incredibly successful in explaining a wide range of phenomena, says a Nobel laureate. But it's clear that it's not the whole story. These observations are forcing us to rethink some of our most basic assumptions about the universe. One of the key assumptions being called into question is the idea of an isotropic universe. Isotropy is the principle that the universe looks the same in all directions, regardless of where you are. This principle is a cornerstone of modern cosmology, but the JWST's observations suggest that the early universe may have been far more varied and complex than we thought. If the universe is not isotropic, it means that our models are missing something fundamental, says a researcher. We may need to develop a new framework for understanding the cosmos, one that can account for these strange and unexpected phenomena. Another major puzzle in cosmology is the nature of dark energy. Dark energy is a mysterious force that is driving the accelerated expansion of the universe. It is thought to make up about 68% of the universe's total energy content, but its exact nature remains unknown. Dark energy is one of the biggest mysteries in science, says a Nobel Prize-winning physicist. We know it exists because of its effects on the universe's expansion, but we have no idea what it actually is. The discovery of dark energy was made in the late 1990s, when astronomers observed that distant supernovae were fainter than expected. This suggested that the universe's expansion was accelerating rather than slowing down as previously thought. The discovery earned the researchers involved the Nobel Prize in Physics in 2011. But now, the JWST's observations are raising new questions about dark energy. Some scientists are beginning to wonder if dark energy might not be as uniform as we thought, or if it might not exist at all. The JWST's observations are challenging our understanding of dark energy, says a researcher. If these galaxies are as old and massive as they appear, it could mean that the universe expanded much faster in its early stages than we thought. This would have profound implications for our understanding of dark energy. As the JWST continues to explore the cosmos, it is likely to uncover even more surprises. These discoveries could lead to a revolution in our understanding of the universe, one that could rival the Copernican revolution in its significance. We are on the brink of a new era in cosmology, says a Nobel laureate. The JWST is giving us a glimpse of the universe that we've never had before. It's showing us that the universe is far stranger and more complex than we ever imagined. But with this new knowledge comes new challenges. Scientists will need to develop new theories and models to explain the strange phenomena being observed by the JWST. This will require a collaborative effort across multiple disciplines, from astronomy and physics to mathematics and computer science. The universe is full of mysteries, says a researcher. But that's what makes it so exciting. Every discovery brings us closer to understanding the true nature of the cosmos. And who knows, the next big discovery could be just around the corner. The James Webb Space Telescope has opened a new window into the universe, revealing a cosmos that is far more mysterious and complex than we ever imagined. From massive bright galaxies in the early universe to the enigmatic nature of dark energy, these discoveries are challenging our most fundamental assumptions about the universe. As scientists grapple with these new findings, one thing is clear. The universe is far from being fully understood. But with each new discovery, we are taking a step closer to unraveling its secrets. And in the process, we may find that the universe is even more wondrous and awe-inspiring than we ever dreamed. So what does the future hold for cosmology? Only time will tell. But one thing is certain. The James Webb Space Telescope has forever changed the way we see the universe. And the journey of discovery is just beginning.